Hello and welcome students. Today we are going to see some more new types of problems for integration, and a new type of problem is integral a e raised to x plus b over c e raised to x plus d dx. So where a, b, c and d are real constants. They are real constants. So what's the type? The type is a e raised to x plus b upon c e raised to x plus d. This is the type. So if you want to see the example for this, one example I can write for you. Say we have to integrate 4e raised to x minus 25 over 2e raised to x, 4e raised to x minus 25 over 2e raised to x minus 5 dx. So here what's a? A is 4, b is minus 25, c is 2 and d is minus 5. So this is, you can have number of problems of this type. Now I shall write method for you. What is method? How do you solve this kind of problem? Method is express the numerator in terms of denominator and derivative of denominator. Express the numerator in terms of denominator and derivative of denominator. Now you must be finding this particular phrase somewhere heard. Yes, you are right. If you remember, this method we had already adopted for the problem which was this type. If you remember, we had a problem which was a cos x plus b sin x over c cos x plus d sin x dx. So even for this type, if you remember the earlier lecture, maybe I guess it was I suppose it is lecture number 8. So you can check this. You can check in lecture number 8 or lecture number 7. We have done this problem. There also the method was same. What was the method? Express the numerator in terms of denominator and derivative of denominator. So now you have two problems which can be solved by same method. So now let me take this off from here. So when I say this is the method, what do I actually mean? What we do is we assume the presence of two constants a and b. We assume two constants a and b such that we could express the numerator in terms of denominator with the help of these two constants. So that is numerator, NR stands for numerator, equals to a multiplied to denominator plus b into d by dx of denominator into d by dx of denominator. So this is the method which we are going to follow. So let's solve a problem of that type. This is from exercise 3.2a, second, seventh problem. Integral 4 e raised to x minus 25 upon 2 e raised to x minus 5 dx. So I understand what type it is. It is this type. What type was that? It is this type. So the method will be, we have to express the numerator in terms of denominator and derivative of denominator. And how is that going to happen? That is going to happen with the help of two constants, a and b, capital A and capital B. And what we will do is we shall find those two constants. We will first we will try to write this, and then once we have written it, we shall find out a and b. We will find the value of a and b, and the process of finding a and b is very simple. So I write here let, okay, so this is integral. I have already written this integral to be I, and now my next assumption is I'm writing let the numerator, that is 4 e raised to x minus 25 equals to a into denominator, a 2 e raised to x minus 5 plus b into d by dx of denominator, which is 2 e raised to x minus 5. So I have here 4 e raised to x minus 25, and don't multiply a inside in this step. We shall do it in the next step. 2 e raised to x minus 5 plus b. See, we are not multiplying a inside. We are not multiplying a inside the bracket in this step because we are not able to do that for b. We are not able to do that for b. Once, because in this step we will get the derivative of this bracket. So we will definitely multiply a and b with the brackets, but we shall be doing it in the next step because we will do that both at once. So here b and d by dx of 2 e raised to x minus 5. So 2 e raised to x, derivative of 2 e raised to x is 2 times, I write a bracket here. So 2 times e raised to x, 2 is a constant, derivative of e raised to x is e raised to x, minus 5. So I write a negative sign, and then derivative of 5 is 0. Okay. So subtracting 0 gives nothing. So this is what is derivative of 2 e raised to x minus 5. This is equation number 1 for me. Okay. So the next step I write 4 e raised to x minus 25 and here I multiply a inside. So 2a e raised to x minus 5a, 2a e raised to x minus 5a plus 2b e raised to x. Next step, I take e raised to x common from the first and the last step. So 2a plus 2b times e raised to x minus 5a. And here I have 4 e raised to x minus 25. This is equation number 2. Now from here, what do I get? You can see by comparing the two sides, what you understand. The coefficient of e raised to x is 4, and coefficient of e raised to x is 2a plus 2b on the right side. So on the left side we have coefficient of e raised to x as 4, and on the right side we have coefficient of e raised to x as 2a plus 2b. So this gets me therefore. So here I write therefore 2a plus 2b equals to 4. This is equation number 3. And look at the left hand side for the constant. Here you have the constant as negative 25, and here you have negative 5a. So now since both are negative, this is negative and here also negative, I could easily write therefore 5a equals to 25. I will get 5a equals to 25. So a equals to 5. I got the value of a as 5. What do I do next? I substitute A in equation number 3. I write here using A in 3, we get, what do I get? I get 2 times 5 plus 2b equals to 4. So 2b equals to negative 6, 4 minus 10. So I get b equals to negative 3. So after getting A and B value, I got A here and B here. The next step is I will use this A and B in equation number 1. Okay, I write here, using A and B in 1, we get. So I write here, using A and B in equation 1, we get. What do you get, students? You get here 4 e raised to x minus 25. 4 e raised to x minus 25 equals to A. A was 5. 5 times 2 e raised to x minus 5, okay, plus B. B is negative 3. Negative 3 times 2 e raised to x. Negative 3 times 2 e raised to x, and this is equation number 4. Now here, what is important, students, that you will not multiply. Okay, what have you achieved? That is important. What have you achieved by writing this? The achievement is a great deal of achievement. Why? Because see, you could now express, this is your numerator. You can check, this is your numerator. Okay, this is your numerator. What have you achieved? You have expressed the numerator in terms of denominator. You can check. You can check here. This is denominator. This is denominator. So you have expressed the numerator in denominator and derivative of denominator. This is derivative of denominator. That's the achievement. Okay. Now what I want to tell you all is, see, you will make sure that this minus 3, students get tempted. They get tempted to multiply minus 3 with 2. Okay. But then you will not do that. Don't write minus 6 in the next step, because this is planned. This was planned by you. You only planned to write numerator as denominator and its derivative. So this 2 e raised to x is the derivative of denominator. So why would I disturb if I got it? So the next step is I will write, now once I have written numerator in terms of denominator, I shall now be writing the integral. So I will write, therefore I equals to, I was, what was I? I was this, but 4 e raised to x minus 25 is no more that. It is 5 times 2 e raised to x minus 5, 5 times 2 e raised to x minus 5, plus minus 3 times 2 e raised to x, plus minus 3 times 2 e raised to x, 2 e raised to x. Okay. Yes, you can definitely write this positive as negative, because plus into minus is minus. So if you want, you can write this as minus 3. But even if you don't write, it's one and the same thing. You can do that in the next step. So here I have 2 e raised to x minus 5 inside the bracket and dx. Okay, after this, you all know. Okay, one more thing I want to tell you all here is, never forget the word, transformation in integration, transformation. So if you are thinking that why is sir suddenly coming to this word transformation, my dear students, it is transformation, very important word, because you can check, you are asked to integrate this, but since you could not get a proper result for this, what are you doing? What is this going on? Why this method? Why this method? Why do we need to write numerator in terms of denominator and its derivative? It's all transformation, because if I don't do this, I won't be able to get a proper form where I can apply the results. Okay, so you cannot integrate unless you have a proper result working there. So when I saw the integral given to me, I noticed that there is no proper result working, and hence the transformation began. Okay, the next step is, students, as you all know, I will split the denominator. So it is this upon denominator and this thing upon denominator. So the next step I will write here. The next step is I write therefore I equals to I equals to 5. You know, when I will separately divide, this will cancel with this. Okay, so I'm not writing, it is only 5 minus, plus into minus is minus, 3 times 2 e raised to x upon 2 e raised to x minus 5 dx. And I have already told you why I'm not writing 6. Don't write 6, because you have planned whatever you are writing, it is all your planning. So you are just working on the plan. So the next step is I will write separate integral. So I equals to integral 5 dx minus, here when I write the separate integral, this 3 which I have, this 3 I'll be writing outside being a constant, and integration of 2 e raised to x upon 2 e raised to x minus 5 and dx. So the next step, what I have the next step as, so the next step here is I equals to, this is 5, so this 5 is a constant, it is out, so 5 times 1 dx, that is equal to 5x minus 3. And you all know, students, there is a well-known result which we have been working on, and that is going to be applicable here, and that result is f dash x upon f of x, f dash x upon f of x dx. You know, in an integral, whenever we notice that the integrand is in this form, what's that form? The numerator happens to be the derivative of denominator. Then the integral we write, the answer we write is log of mod of denominator plus c. Log of mod of denominator plus c. So when we apply this, here we get derivative of denominator is present in numerator. So we will get log of mod of 2 e raised to x minus 5 plus c. This is the final answer that we have. This is final answer which we got. So I hope you all must have understood. You can see the video again and again in order to get expertise on it. Let's take a problem. This is same exercise 1 and 16th. Let I equals to 1 over square root of x plus root of x cube dx. So, you know, students, the first thing that I will do is I have got here root x, and here I have got root of x cube. So why not write this as root of x cube? Why not write x square into x, root of x square into x? Okay, so when I write root of x square into x, the next step I will get 1 upon root x plus x root x plus x root x dx. Okay, root of x square, so this square root of x square, this x square is under root, so outside it will only be x. So and then inside x root x is left. So the next step is I shall now in the denominator I will take square root common. So root of x is common, so I get 1 plus x and dx, 1 plus x dx. Okay. Now I follow my steps which I normally follow while substitution. So here, see how do I do it? 1 upon root x, and this is 1 plus, I've got here x. See, I wrote root x here, then inside the bracket 1 plus x. What I have 1 plus x. But you know what I will do? I will write 1 plus root x the whole square. Okay, this is manipulation. I'm manipulating things. I'm writing root x the whole square. Okay, now what I shall do is, this root x I will put as t, this root x. I put this root x as t. So I write here, put root x equals to t, and then I differentiate with respect to x, differentiating with respect to x. So when I do that, d by dx of root x is 1 upon 2 root x, and here I have d by dx of t. So this dx would go that side. I will take dx on the left and 2 on the right. So I get dx, I get dx upon root x equals to 2 dt. What I get? I get dx upon root x equals to 2 dt. So see here, dx upon root x equals to 2 dt. This whole thing, 1 into dx is dx. So for in this integral where I intended to make a change, mind it, I intended to make a change in this integral here where I started with the substitution. What did I intend? I intended that in this integral where I have root x, I would be putting t. So now when I write the new integral, the changes has to be made in this only. So see, the new integral will be I equals to integral, 1 upon root x dx is 2 dt. So I get 2 dt upon, this is already gone, this is gone there. And what else you have? You have 1 plus root x square, which is t square. So I have 2 out and 1 upon 1 plus t square dt, 1 upon 1 plus t square dt. And we all know, students, if in case if you forgot, I will tell you what is d by dx of, tan inverse x. D by dx of tan inverse x is 1 upon 1 plus x square. So if derivative of tan inverse x with respect to x is this, so what is integration of 1 upon 1 plus x square dx? Definitely it is tan inverse x plus c. By definition, if derivative of this is this, so integration of this would be tan inverse x. Okay, so 1 upon 1 plus x square dx is tan inverse x plus c. Here what we have? Here we have tan inverse. Here we have 1 upon 1 plus t square dt. So it will be tan inverse t. So I have I equals to 2 times tan inverse t plus c. That is 2 times tan inverse of t is root x plus c. Very, very good question it was. Please copy this. Let's take one more problem from the same exercise. This is first 20th question. We have to integrate. So here we are solving problem number 20, which is, I assume that given integral to be I as x raised to 5 into square root of a square plus x square dx. So what is my integrand? This is the integrand which I have to integrate. And here what I understand, students, I understand that the kind of results which I am aware to, those results are not working here. So definitely what I will have to do, I will have to go for transformation. And that transformation I will achieve only by substitution. This is a good question. This is a very good question which we are solving. So this will teach us a lot. Let's solve this. So, here what I will do, I will write first as I will write this as x raised to 5. I will write x raised to 4 and then square root of a square plus x square and x dx. Now, what did I do? This x raised to 5, I wrote x raised to 4 into x. X raised to 4 into x. Okay. Now, why am I doing so? That you will achieve, that you will understand in a minute or two. So the next step I will write x raised to 4, I will write as x square, the whole x square square, and this is a square plus x square into x dx. A square plus x square into x dx. Okay. Now for me, the great difficulty which is arising is because of a square plus x square. The difficulty that is arising is from a square plus x square. Okay. So what I will do is I will try to remove this, eliminate this square root by putting a square plus x square as t square. What did I say just now, students? I said that I'm facing a difficulty in integration because of this square root which has got a square plus x square inside it. Now somehow I want to remove this square root. So see, for that what I will do, I will write put a square plus x square. I write a square plus x square equals to t square. I write a square plus x square equals to t square. Okay. Then I write here differentiating with respect to x. Differentiating with respect to x, I get here d by dx of a square plus x square equals to d by dx of t square. D by dx of t square. Okay. And the reason for substituting a square plus x square as t square is only that I wanted to remove the square root. If I substitute this as t square, it is needless to say square root of t square. If I'm putting the content as t square, so square root of t square, it will be t, and I will have no square root there. Okay. So the next step I get d by dx of a square is 0 and d by dx of x square is 2x, and this side I have d by dx of t square, which is 2t into dx by d by dx of t. This is d by dx of t square. So t square derivative will be 2t into d by dx of t. So 0 plus 2x is only 2x. This dx will multiply here. So I have 2x dx equals to 2t dt. So this 2 cancels and I get x dx equals to t dt. And students, if you see here, I had already made a provision for this substitution. You check here, I had already written x raised to 5 as x raised to 4 into x, because I had made a plan that when I would be substituting this as t square, the derivative would get me x dx. When I'll be putting this as t square, I was sure that a square plus x square, after differentiating, I would get x into dx. So this plan was made at that point in time only. Now I'm going to write the new integral. The new integral now will be in t completely. Okay, so see here, x square the whole square. Now x square the whole square, what would you be writing for that? You x square you will write t square minus a square. See, we are changing this integral which is in x. Now we are writing a new integral for that in t. So x square the whole square. X square you will write t square minus a square. So integration of t square minus a square the whole square, t square minus a square the whole square, and then square root of a square plus x square is t square, and x dx is t dt. So the next step you have, students, so this is complete square. I will write this as, I will apply the identity. So it is t square the whole square, t raised to 4 minus 2t square a square plus a raised to 4 plus a raised to 4, and here I have square root of t square is t, and then again one more t, so I have t square and dt. So next is what? So I equals to, you multiply t square inside, so t raised to 6 minus 2a square t raised to 4. I'm multiplying this t square inside, t raised to 6 minus 2a square t raised to 4 plus a raised to 4 t square and dt. Now, so I will write I equals to integration of t raised to 6 dt minus 2a square is out, integration of t raised to 4 dt plus a raised to 4 is out, and you have integration of t square dt, t square dt. Okay, so the next step we will have integration of t raised to 6 dt is t raised to 7 upon 7, t raised to 7 upon 7 minus 2a square, and t raised to 4 dt is t raised to 5 upon 5. Okay, so minus 2a square t raised to 5 upon 5 plus here I have a raised to 4 t square dt. So a raised to 4 and t cube upon 3 plus c. Now what I will do, students, I will resubstitute what t was. What was t? You had substituted t square as a square plus x square. So t would be square root of a square plus x square. You need to write the final answer in x as the question given was in x. The given function to be integrated was in x. So after you have integrated, you will have to write the final answer in x only. So root of a square plus x square. So here you have root of a square plus x square raised to 7 upon 7 minus 2 upon 5a square, and root of a square plus x square raised to 5 plus a raised to 4 upon 3, and root of a square plus x square the whole raised to 3. Okay, so a raised, you know that square root of a number, if I have square root of a, so it is a raised to half. So if I have square root of a raised to 7, then it is a raised to half raised to 7, which will be a raised to 7 by 2. It will be a raised to 7 by 2. So what I will do here is this will become 1 upon 7. This will become 1 upon 7 a square plus x square raised to 7 by 2 minus 2 upon 5 times a square, and a square plus x square raised to 5 by 2 plus a raised to 4 by 3, a raised to 4 by 3, and a square plus x square raised to 3 by 2 plus c. This is the final answer. Okay, you must practice such questions several times. Students, solving these type of questions several times actually gains a lot to you. This was a good question. You can check this once again. Thank you. Let's solve a new type of problem now, and the type is integral ax plus b upon square root of px plus q. So in this type of problem, what we have the numerator, which is a linear algebraic function of x, and the denominator is also linear. So this type is also named as integral linear divided by square root of linear. It is also written as linear divided by square root of linear. Linear divided by square root of linear. Ax plus b upon square root of px plus q. Linear upon square root of linear. What is method, students? The method is very interesting because this method is somewhat taking you close to the previous problem that you solved. I mean, this problem here, what helped, what help had you sought for? You thought of removing the square root, and for that, what did you do? You substituted the content of the square root as t square. So the same thing we would be doing here, because it is very simple, students, that if you substitute the content of the root as t square, so it would be root of t square, and the root of t square gives you t. Root of t square gives you t. Okay, so t into t, this becomes t square here. So here what I will do is, I want to remove this square root. So I will write here, put the content of the square root, that is px plus q equals to t square. This is the method. And definitely if you are substituting px plus q as t square, you are substituting an expression which is in x in t square. See, if you are substituting px plus q as t square, what are you doing? On an expression in x you are putting as t square. So the new integral which you will get, it is needless to say it will be t square. Okay, now remember students, if px plus q is t square, so this numerator which is ax plus b, it will not work anymore. What you will have to do is from this substitution you will find out the x value. So it will be px equals to t square minus q, and x will be t square minus q upon p. So for ax plus b, you will not write ax, rather you will write a. X you will write t square minus q upon p plus b. Okay. So see, this is how everything is now turning out to be an integral in t. Here you had integral in x, now you are writing integral in t. Moreover, now having written this whole integral in t, you know this expression which was in x, you are now writing in t, and the whole integral after you have written in t, this differential should also be changed. It is dx, which should now become dt. For that, what you will do, you will differentiate both sides with respect to x, and then you will get something dx is equal to something dt, and that you will write here. So this will also be in dt. This will be in dt. Here you will have dt. So these all will come into effect when I solve the problem. So this is all mandatory steps which always happen whenever there is a substitution taking place. So as of now, what you will understand is the method is remove the square root. The method is remove the square root by putting the content of the square root as t square. That is the main step which you will have to remember. Okay, put px plus q equals to t square in order to get rid get rid of get rid of square root. Get rid of square root in the integral. Okay, now rest of the things will follow this. No need to write we will have to differentiate, then write everything in t. All that is mandatory, you know, it always follows. So this is one problem. Okay, now there is one more type, students. That type should also be mentioned here because that type also goes hand in hand. That type also goes hand in hand. So that type is one more type of the similar nature, and it is integral ax plus b multiplied to square root of px plus q. Okay, and dx. So here what I have, here I have ax plus b multiplied to square root of px plus q. Once again I notice that inside the square root I have got a linear function, and outside I have got a linear function multiplied. But then what is the difference between these two problems? What's difference between this type and this type? The difference is here the square root, in the first one the square root was in numerator, whereas in the first one the square root was in the denominator, whereas in the second one the square root is in numerator. Will that change our method? Definitely no, it will not change our method. Okay, what more, students? What should I write? What other name can we give to this? We can give this a name. This is linear multiplied to square root of linear multiplied to square root of linear dx. This is another name that we can give to this problem. And what is method? Method is same, exactly same method we are going to apply here. The method is put put px plus q equals to t square. And why that? In order to get rid of the square root in the integral. Now what I'll do is I will solve a problem for you all. So let's have a problem here. I solve question number 21. So I will solve question number 21. It says let I equals to 5 minus 3x, 5 minus 3x multiply to 2 minus 3x raised to negative half and dx. Okay, what would I do? As I have already told you, 5 minus 3x, this I will write in the denominator, so that makes the power positive. 2 minus 3x raised to half. Okay, the it will be the positive power raised to half and dx. Now raised to half, so it will become square root. So here you will have 5 minus 3x upon, it will be square root 2 minus 3x and dx. This is I. Okay, so is this my, or is this my type which I explained you just now? Definitely yes, definitely yes. This is the type. What was the type? The type was linear upon square root of linear. Okay, and what the method was, students? The method was put the content of the square root as t square in order to get rid of that square root. So I write here put 2 minus 3x. And don't forget, my dear students, why are we doing all this? It is because the given integrand which I wanted to integrate, this one I am unable to apply a result. This all we are doing, in order to end up, at some stage we will end up with some form where I can apply the result. That is why we are doing all this. This method, this is known as transformation. We are just trying to write for the given integral one form where we can apply the result, those results which we have learned in the beginning of the topic, and we keep adding on into those results as we go ahead into the topic. So we put 2 minus 3x equals to t square, which is the content of the square root. Then I will write here differentiating with respect to x. When I differentiate with respect to x, I get 0 minus 3 into 1, and d by dx of t square is 2t into d by dx of t. D by dx of 2 minus 3x is 0 minus 3. Now this dx will multiply here, so I'll get minus 3 dx equals to 2t dt, but I have only dx here, so dx is negative 2 by 3 t dt, negative 2 by 3 dt. Now I write I, so finally now I write I here. I is equal to, as you know students, when you are planning to write the new I, it will be completely in t, because dx is now going to be written in terms of dt. The differential has changed, so the variable will also change, or vice versa. The variable has changed, so the differential will also change. When you have x, you have dx. Now here you are going to write everything in t, so you will write dt. Okay, what more students here I will have? Here I shall now take the value of x. I will find out x value. So x is 2 minus t square upon 3. This is x. Okay, if 2 minus 3x is t square, so 3x goes that side and t square goes this side. I have 2 minus t square is 3x, and x is 2 minus t square upon 3. So I have here 5 minus 3x. I noticed that I could have directly substituted 3x value. I could have directly substituted 3x value. It's okay, no problem. So 5 minus 3, and what is x? I found x as 2 minus t square upon 3, and square root of what I found for 2 minus 3x. 2 minus 3x I substituted t square, And then what is dx? Dx is minus 2 upon 3 t dt. Okay, minus 2 upon dx is minus 2 upon 3 t dt. Okay, this 3 and 3 cancels. So the next step I have is I equals to integral. Okay, 5, I open the bracket, so I get 5 minus 2 plus t square, and denominator I have t, denominator root of t square is t, and here I have negative 2 by 3 times t dt. Okay, what next, students? The next is you are going to cancel this t, so t cancels, and this minus 2 by 3 will go outside because it's a constant. So I have next step as I equals to negative 2 by 3 outside, negative 2 by 3 outside, and 5 minus 2 is 3 plus t square, 3 plus t square, 3 plus t square, and dt. Nothing else, nothing else. See how simple it has become. Oh, bingo. Negative 2 by 3, and then I write separate integral, integral of 3 dt plus integral t square dt. Okay, so I have here negative 2 by 3, negative 2 by 3, and 3 is a constant, so 3 out, integration of 1 dt is t, plus here I have t cube by 3 and plus c, t cube by 3 plus c, t cube by 3 plus c. So the next step I have is, now I resubstitute what t we had taken. Okay, before that let me multiply this my negative 2 by 3 inside. So I have negative 2t, 3 cancels, negative 2 by 9 t cube plus c. Okay, and what was t value? So since t square was 2 minus 3x, t will be root of 2 minus 3x. So I have negative 2 and square root of 2 minus 3x, negative 2 over 9, and square root of, it is square root of 2 minus 3x raised to 3 plus c. So it will become negative 2 times square root of 2 minus 3x, negative 2 over 9, and this is 2 minus 3x raised to 3 over 2 plus c. This is final answer, students. You can see the whole thing once again, the whole solution you can see several times unless you understand. Very interesting question this was. Thank you. I hope you understood this. So based on the problems which we solved recently, these two problems you will all try. That is integral. You will all try integral 2x plus 1 square root of x plus 2 dx, and 22nd you will also try I equals to 7 plus 4x. This problem could be challenging a little bit, not much, but you can always find a solution if you have a will to do so, and I'm sure you will all try doing this and you will definitely be success. So this one also you will try 7 plus 4x plus 5x square upon 2x plus 3 the whole raised to 3 by 2. Solve these two problems, students, and get the answer for these two. I shall get you the answer if you have a doubt in the next class. Thank you so much.